So here's another example in which, in this case, we're going to deal with a triple bond. Again, there's two ways of doing this one. In the first way, again, remember we have what it looks like to be a CH3 on the left. Let's write that down. Next to it, or bound to it, is a CH2. There you go. And notice now we have two carbons of the triple bond. Notice those two carbons don't have any hydrogen on them at all. Why? Because, well, they have the required number of bonds between them and other carbons that are attached to them, and they don't require any hydrogen. Also, if there was hydrogen on these carbons, it should be shown in the actual Lewis structure. You don't see them, so obviously there isn't any on those carbons. So let's go ahead and put that first carbon of the triple bond right in there. Put the triple bond in as such, add the other carbon of the triple bond, and you're finished with the two carbons of that triple bond. You're left with the CH3, and we'll just tack that on the right side, and that's your first method of doing that. Now, there's another way of doing this, and this second method involves basically removing or dropping the triple bond. So if you do that, here's the second method. Things are going to get even simpler, and you're going to end up with that as your other possible structure. Notice that the triple bond is not shown, and that is perfectly fine. That is a correct structure. This is perhaps a little more clear than the other structure we've drawn over there, but this one here is more compact. You may be a little confused as to, well, how do I know that there is a triple bond in there? Well, how do you figure that out? Well, use what you know to be your normal bonding patterns, just like we learned in class. Remember that carbon likes to have 4 bonds, some combination of single and multiple bonds. Always going to equal 4. Now, that's not always true. You could have a charged species that has less, for instance, like a carbocation or carbanion. We'll talk about those later. But for right now, it's always going to want 4 bonds. So how do we figure that out? Well, let's just re-expand this, and maybe I can give you some guidance here. Notice you have a CH3. We're going to re-expand that right there. Notice you have a CH2 attached to that CH3. There it is, CH2. Whoops, let me move this up a little bit more. Now we have the 2 carbons of the triple bond. Now this left carbon is bound to what? This carbon there, so I can put a bond in, and there's the left carbon of the triple bond. And notice it's also bound to the right carbon of the triple bond. Okay? On the right-hand side here is another CH3. So I'll put that in just like that. Now we can go back in and put the multiple bond in. Notice that these 2 carbons, how many bonds does this one have? 1, 2. It needs to have 2 more. So we can give it 3 and 4 by putting a multiple bond in. And when we do that, it also works well for this carbon here. So now it has the required 4 bonds. So now we're done. So all you have to do is work back through the structure, make sure every single carbon atom has the required 4 bonds, some combination of single and multiple bonds. If you don't see any hydrogen here, you're going to know that there's going to be more bonds between those 2 carbons, and that can help you as well.